Hello, I'm Jason with scienceandmath.com, and today we're going to build a very simple electric motor that you can build really out of 3 components. Take you about 10 minutes, and I guarantee you once you know how to build it, put it on your desk or put it on the table and just kind of let people watch it. They'll kind of stare at it and say, well, how does that work? Because it looks really neat, and it just kind of sits there spinning over and over and over until the battery runs down. So let's learn how to build it. It's very, very simple to do. All you'll need to build this little guy is a AA battery. Go and get a new battery. You'll need some copper wire. This is solid copper wire. There's no insulation on it. It's just sort of bare copper. And you will need a magnet. This is a rare earth magnet called a neodymium magnet. You can find them usually at the science supply store, or you can find them certainly online. Usually just cost a few dollars for a magnet like that. You can type into a search engine rare earth magnet or neodymium magnet and find these guys. So believe it or not, that's really all that's required to build this, and there's many, many ways to build a motor. There's many, many designs for motors, but this is really one of the simplest ones and one of the neatest ones. So we want to go ahead and put our safety glasses on just so we have them, just so we can be safe. And I have a pair of scissors here. These are sort of shears that I'm going to use to cut this wire. So really, again, this is solid copper, and you can sort of see the texture of it, so to speak, how much it bends. I mean, it's very easy to bend into whatever shape you want. So the exact size, diameter, and all that doesn't really matter. You just want to get some sort of wire that you're able to bend. And by the way, this would work if you had some kind of really solid copper wire with insulation on there. It should work. You'd have to make a few modifications to it as long as you have the copper in the middle. So go ahead and make a quick cut, and then we will just sort of put this off to the side. We don't need that anymore. And basically what you're going to do is you'll just take your battery and your magnet, and you will stick the magnet to the bottom of the battery like that. So that's not going anywhere. And ultimately, what the entire device will consist of is you'll put it on the desk and let it sit there, and this piece of copper that we're about to make is just going to spin around and around and around until the battery goes dead. And we've already built a different type, very similar but slightly different type of motor in this experiment series already. They're both really neat. This one, to be honest with you, I kind of like it a little bit more because you can sort of sit it down and just let it do its thing, and just people can just watch it. So what you want to do is take your long strand of wire, and basically you want to fold it in half. So you take it like this, and by the way, there's no hard and fast science to this. I mean, as far as how to build it. There's science as far as how the motor works, but there's no one way to exactly do it, I guess is what I'm trying to say. You'll see very quickly how we're basically building the thing, but as far as like the exact way you fold it, the exact way you shape it, the exact way that you form the thing, doesn't really matter that much. So what you're trying to do is basically make a little point here, and then once you get it into a point like this, you want to sort of make almost like a golden arches out of it, like this. So we're going to turn it upside down, and we're going to bend it like this. Or you could look at it as a bird, you know, a little flapping bird, whatever you want to do. But basically you want it to be in a little point like that, and kind of coming up sort of like a golden arches. Now, the reason we're doing that is because really what you want to do is you want it to balance on top of this battery, the way we have it here. Okay, you want to balance it. And the reason is because it's going to just go around and around in a circle like that. Now, one thing you can help with that, I didn't put this in the materials list because it's optional, but if you just get yourself a little screw, and here in the top of the battery here, if you just sort of push on it very gently with a screw like this, you can make a little indentation. You don't want to do it too much. You don't want to, rupture the battery, but just do a little indentation there, right on the top. And that can help because, like I said, ultimately this thing is going to be spinning around and around, so a little indentation there can sort of help it stay on track, so to speak. Okay, now what we're going to do is, let me go ahead and set it up like this. What we're going to do is have it basically like this. We'll go a little bit higher like this. We'll have it basically like this. Now what we want to do is we want to sort of mark where the magnet is at the bottom. So if we sort of put it there, the magnet is going to be there. So keep your finger there, and what you want to do is sort of bend that in like this, right? You want to bend that in. You want to do the same thing on the other side. And you can sort of see what I'm talking about when I say there's no exact science to exactly how to build these things. You know, it's going to be your own little creation when you're done with it. Right? So if we put it like this, we should have these two little pieces crisscrossing right on top of the magnet. Basically, you're making a circuit where the electricity can flow out of the battery and down through the magnet. And of course, since the magnet's connected to the other part of the battery, it just kind of makes a circuit of electricity like this. Okay, so what we want to do is, as we place this guy on top, like this, we want to be able to touch the top and have the bottom two pieces touch the magnet down here. And we'll let go. And you can see it already sort of started to spin. So you can sort of let go, and you can see it spin and it sort of falls off. So this is the basic motor. You can sort of see it spinning as we do our thing. The only problem is it's really not stable, because since the bottom here is sort of open, as soon as it starts spinning, a lot of times it's going to fall off, and that's no fun. So what you really want to do is sort of bend the bottom here. If you can kind of see, down by the magnet, what you really want to do is bend these bottom pieces to kind of curve around your magnet and sort of grab onto it. And that can take a few minutes to do. So I've already done it basically right here. And you can sort of see the difference. So here's the one I just created here. You want to kind of curve these two pieces down here. And so that's what I've done in this one right here. You can sort of see this guy curve down like that. So if you do that, then what you're going to have is you'll just kind of, you can see how it's kind of loosey-goosey down here. You can just kind of go and slide it on top and touch it there and let go and see what happens here. And we can see that it is spinning nicely, and it just sort of continues to go and go and go. And that's the nice thing about this motor. It's very simple to build, just takes a few minutes, and you can literally have this sitting out on your desk. If you're a teacher, just kind of have it sitting out. If you're just working in an office environment, just grab it out of your desk, put it out, and this thing's going to continue to spin until the battery's dead. All right, now it's time to try to understand exactly how this is working. And you know, the exact details of how it's working, you could use math, you could figure out exactly how fast it's going to spin, the direction it's going to spin, and all of that. And I'm not interested in really giving a math lesson right now, but what I am interested in doing is trying to teach you basically how it works. So what you have here is very simply a wire connected to the top of the battery, the positive terminal of this battery, and then you have that wire coming around and taking the electric current down and dumping it into this magnet. And now you need to know also that this magnet conducts electricity. So when the electricity goes into this magnet, it's allowed to go straight back up into the battery. So you've completed a circuit on both sides really, and you've allowed the electricity to kind of come out and back and come back down into the magnet. Now, what this does is very, very important, is really the key to the whole thing working. The one thing you need to know how any magnet or any motor works, any kind of motor that turns when you put electricity into it, they all basically work the same way. Motors work because of one fact of nature, and that is the following. If you have a magnetic field, and we have a magnetic field around this magnet here, if you have a magnetic field, then if you have an electric current flowing through a wire in that magnetic field, then there's going to be a force on that wire. Okay, that's always going to happen. That's something that you learn when you get into physics classes and things like that, and that's how all motors work. And I'll say it one more time. If you have a magnetic field and then you have a current like flowing through a wire that's placed inside that field, there's going to be a force that's going to pop up and act on the wire. Right? Now in this particular case, the direction of the magnetic field, that's all invisible by the way, you can't see the magnetic field, but it's here. The direction of the field and the direction of the current line up in such a way to cause a force to want to push this guy, which direction? In the clockwise direction. So the current is flowing down through and going in this direction. The magnetic field is down there around that magnet, and the two directions of the magnetic field and of the current tend to put a force on this side of the wire pushing this way, and on this side of the wire pushing this way. So what you get is a net turning effect. So the force on this wire is going that way, the force on this wire is going that way. One thing that might be kind of nice to see is sort of like a picture. This magnet that's on the bottom is basically like a cylinder like this, right? And you can't see it, but there is a magnetic field that's coming around there. So the direction of that magnetic field comes from the top face, and kind of goes invisibly out and kind of comes back to the bottom face, and it has some kind of direction to it. That's why I have arrows here. So the magnetic field over here kind of circulates like this, right? So, you know, I could keep drawing lines, but I don't want to clutter up the drawing. Basically, you have, you know, going from the top, coming down to the bottom, going to the top, coming down to the bottom. And it's in 3 dimensions, so no matter how you look at it, there's always an invisible magnetic field coming from the top and going to the bottom. But mainly what I'm wanting to show you is that there's a direction to this magnetic field. There's a direction to it. If you take the magnet and flip it over, the direction of all these arrows is going to be backwards, right? You can kind of just sort of see that. If I turn the magnet upside down, then the arrows are going to basically point the other direction. So what this means is that if in this configuration, if when we have the magnet like this, if the force lines up to want to turn this guy in the clockwise direction, what do you think is going to happen if we flip the magnet over? Right? So let's first of all look at it exactly the way we built it, like this, and we can see that the motor wants to turn in the clockwise direction. All right? So what we'll do is we'll flip the magnet over, that's all I've done, put it back into place. And basically what we're doing is that the electricity is still flowing in the same way. The electricity is still coming out of the top of the battery and flowing down towards the bottom and going into the magnet in the same way. The electricity is doing the same thing, but the difference here is that the magnet is flipped over. So the magnetic field is flipped over, and that's causing the force on these wires to be reverse of what they originally were. I'm Jason with ScienceandMath.com. I hope you've enjoyed this segment where we've learned how to build a very simple motor, probably one of the simplest motors that you can build, that you can just build it, put on your desk, and sort of gingerly watch it spin around. Now I'll tell you, if you spend some time and get the bottom of it looking just perfect and get some pliers out and shape it to the circumference of that magnet down there, you'll get a perfect fit, and you can just let it go even faster and faster. It's very, very simple to do, but it does take a little bit of time to get that bottom exactly correct so that it's always touching that magnet. So spend some time, play around with it, but even if you don't do that, it just takes 5 or 10 minutes to build this thing. You could literally whip that up while someone's sitting right in front of you and just amaze them and show them what's happening. And never forget, what's really going on here is you have an invisible magnetic field down there, and then you have this battery sending electric current into that field, and anytime you have electricity flowing inside of a magnetic field, there's going to be a force pop up. And in this case, that force is pushing the wire, you know, both sides of the wire in different direction, and that's causing the turning motion.